In this problem, we have someone named Alice on a rocket going from Earth to another planet called Zorg, where Earth and Zorg are uh, not moving relative to each other at some speed v, which is 8/10 the speed of light. And we want to know how many years it takes for Alice to traverse this 23 light year distance within her own time frame. Or put another way, how long does Alice experience on this journey? Probably the most conceptually simple way of solving this problem is going into Alice's own frame of reference and seeing how much time she experiences. So if we were to do that, we have the Earth here, we have our rocket with Alice on it, and the rocket is now motionless because this is Alice's own frame, and the universe is moving around her. So the Earth is moving away with speed v, and planet Zorg is moving towards her with speed v. And crucially, due to length contraction, the distance that Alice perceives between Earth and the planet Zorg is actually shorter than the distance that Bob, our observer on the planet Earth, perceives between these two. So this is going to be some distance L. And we know that our generic formula for length contraction is L equals our original distance of 23 light years times the square root of 1 minus v squared. So that's 0.8 squared c squared over c squared, and the c's cancel out. So we have an expression for the distance that Alice sees, and the planet Zorg is moving towards her with speed v, where v is still 0.8 c, and we know that distance equals velocity times time. So the amount of time that it takes is just going to be the distance over the velocity, which tells us that t is going to be L over v, which is just 23 light years times square root 1 minus 0.8 squared over 0.8. 1 minus 0.8 squared you can find using a 3, 4, 5 triangle by the Pythagorean theorem. If I have a triangle that's 1.8, this is going to be 0.6, and this is an equivalent expression to the Pythagorean theorem, so this is going to be 0.6 over 0.8 times 23. This should be 0.8c. C's cancel out, so we're left with just years. So this is 0.6 over 0.8 times 23 years, which is 3/4 of 23, which, if we plug that into a calculator, that's 17.25 years. So this is how long Alice is going to experience this journey taking. An alternative way we could do this problem is using time dilation. So we know that for time dilation, it's kind of the opposite of our length contraction formula. We know that t equals t prime equals t over square root 1 minus v squared over c squared. And we know that from the observer on Earth's perspective, this journey is going to take 23 years, and the amount of time that the observer is going to see Alice experiencing is going to be slower. So for Alice, since she's experiencing time more slowly according to the observer on the Earth, the time that it overall takes her in her own perspective from the observer on Earth is going to be less than the observer on Earth. And this is going to be t equals square root 1 minus b squared over c squared times the time that it takes, which is again going to be 25 light years over the velocity, which is again 0.8 c. And this is the same expression that we had earlier. So those are the same. Okay, hopefully this was helpful.